Welcome to solverfy.
This is the answer to Chapter 21, problem number 71 from the Smith Organic Chemistry textbook. And this problem introduces Celebrex or rofecoxib, which is trade name Celebrex. And we're asked to draw a stepwise mechanism for this reaction in the synthesis of the drug. And so this is a pretty serious mechanism. And I do just want to note before I begin, I'm going to be using the notation that I lay out here on this first page. So I'm going to be abbreviating the one phenyl ring with the methyl group as AR. And in the other molecule, I'll be abbreviating the whole sulfonamide group as AR prime. Okay. And hopefully that will make this much easier and faster to write. All right, so the first step of this mechanism, the hydrazine is going to attack this carbonyl here. These electrons will go up to the oxygen. And so after this first step, we are here. Okay. And so the nitrogen is now going to have a positive charge on it. And this oxygen is going to have 3 lone pairs and a negative charge. And so the next step is going to be a proton transfer. So we can just write proton transfer. And after that, we will be here. So that takes care of our charges. Okay. So from here, what needs to happen, and we are told in the problem that there is HCl in this reaction. So this alcohol is going to be protonated. So it's going to grab that acidic proton. So this oxygen now only has 1 lone pair, and it has 3 bonds, and so it has a positive charge. And so what can happen from here is the lone pair on this nitrogen can attack here to form a double bond, and this water is willing to leave. It's a good leaving group now that it's protonated, now that the alcohol is protonated. And so when that happens, we get to here. So I'm going to put the CF3 up here now. It's going to make this sort of easier to look at and work with. So here is our double bond to the nitrogen. The nitrogen has this proton as well as the other nitrogen, and then that has the AR prime group on it. Okay, and so of course this nitrogen is going to have a positive charge. It has 1 too many bonds. Okay, and so the next thing that's going to happen is deprotonation there. And that is going to be accomplished by an equivalent of water. Okay. And so from here, what can happen is we're going to form our third ring, and that is going to be accomplished by this lone pair on this bottom nitrogen attacking this ketone. And that is going to form a 5-membered ring. So our CF3 is here. This nitrogen has double bond. And then the alkoxide, the remainder of that ketone, is right here. So 3 lone pairs and a negative charge. Okay. So next we're going to do another proton transfer. So again, we can just write proton transfer. And you know what? I forgot to put the positive charge on that nitrogen, but so there it is now. And so after this proton transfer, that's going to resolve our charges. So this will now be an alcohol. Okay. And so now basically we just need to get rid of that alcohol and form the second double bond in that new ring that we made. And that is going to be accomplished by another equivalent of HCl. So this alcohol is going to be protonated by another equivalent of HCl. And so rather than try to squeeze all this in on one page, I'm just going to go to another page. Okay, so let me redraw this quickly. Okay. So here we have our protonated alcohol. So the oxygen only has 1 lone pair and it has a positive charge on it. And so the next thing that's going to happen is the lone pair on this nitrogen is going to add in here, and this protonated alcohol will leave as water. Okay. Protonated alcohol leaves as water. And then the final step is going to be deprotonation here to get the double bond in the final position that the double bond is going to be in. And so we can use another equivalent of water to do that. So this water can grab a proton. Those electrons can go there. These electrons can go back to this nitrogen, which of course had a positive charge on it that I omitted. And so that is going to be our final product. Okay, so there we go. That is celecoxib. Yeah, and so that's the stepwise mechanism that accounts for its formation. It's a pretty complex mechanism, pretty time consuming, unfortunately, but it is just a nitrogen nucleophile attacking a ketone, and then the ketone, the alcohol that results from that ketone being protonated and leaving, and then really the same series of steps happening again to get to the final product. Okay, and again, here on page 1, these are the abbreviations that I used. It's pretty common to see AR. It stands for aryl, so it's used to represent, a large part of a molecule that involves an aromatic ring. And that's the answer to chapter 21, problem number 71.